Assalamualaikum students. So today we will talk about transformers. So what is a transformer? It is a device which is used to increase or decrease the EMF or current. So what is the function of the transformer, or what is the working principle of transformer? So the working principle of transformer is electromagnetic induction, means it is going to induce the current from one coil to another coil. Now, the thing is that why we use the transformer? What is the function of the transformer? Like, for example, when you talk about in our homes, the basically input of the voltage is 220 volt, and like for example, when you talk about your mobile phone, they basically charge on a 5 volt. So we have to basically step down the EMF of the input current. So for that, we use as transformers to basically step down the voltages from 220 volt to make it 5 volt. Okay, so that's the phenomena behind the transformers. So when you talk about the transformer, basically there are two types of transformer. One is a step up transformer, and the other one is the step down transformer. Step up transformer are those transformer which is used to increase or which is used to improve the EMF, while step down transformers are those which is used to decrease the EMF. Okay, now okay, one more important thing is that when we are considering these two things, if we are increasing the EMF, along with that, we have to keep this in mind that if we are increasing the EMF of a system by using the transformer, the current across that circuit is going to reduce. Okay. Similarly, if you are decreasing the EMF, the current would increase, or that circuit will increase. Okay. Now, what are the basic components of the transformer? So the basic components of the transformer is a soft iron core. After that, we have a primary coil and a secondary coil. As why we are using a soft iron core, the reason behind is that it can magnetize easily. So I want to show you the picture of the transformer. Now this is a transformer. This one is your iron core. This is your iron core. It is going to be a soft iron core. So I'm writing soft over here, soft iron core. Along over here on the right, on the left side, this is your left hand side. So on the left hand side, we have a primary coil, and on the right hand side, we have a secondary coil. Now, there are some number of the coils. So these number of coils are known as turns. Okay, so these are the turns of coils. Okay, now at this part, we are basically providing some initial voltage. Okay, so we basically called it VP, and over here at the secondary coil, we will get the output. So the output is represented with VS. Okay, voltage is going to be represented with VS. So the number of coil in the primary, the number of turns in the primary coil is represented with NP, and the number of turns in the secondary coil is basically represented with NS. Okay, so these are few things that you should know uh, before we move to the further into the topic. Now, okay, so when you talk about the construction of the simple transformer, basically it is made of a primary coil and a secondary coil wound around a soft iron core. The coil which relates to the input voltage is known as primary coil, as I defined over there. That this is the input portion, and this is your output portion. So this is your output portion, and where this is your input portion. Okay. So the input portion is basically called the primary coil, and the output portion is usually called as the secondary coil. Okay. Okay. Now the coil which is related to the output voltage source called the secondary coil. This is again a diagram, and this diagram is actually this one. Okay. So this is a soft iron core. Okay. This is the you can say that in a paper whenever they ask you about the transformer, so you have to make this diagram. Okay. Now let's go with the types of first we will talk about the working mechanism. अच्छा बेटा when you talk about the transformers जो होते हैं they basically work on the ACs. Okay, we for this we need the alternating current. So initially what we do there, we provide the alternating current to the primary coil, which produce the magnetic field in the soft iron core. This magnetic fields, or basically this magnetic fields cuts or interact with the secondary coil, and the rate of change of the magnetic field which occurs in the secondary coil will result in the induction of EMF in the secondary coil. It means that just over here, these coils are actually, and just give me a minute. Okay, so what happened over here? The coils, as we have some number of coils over here in the primary portion, in the primary sector of the transformer. So these the current is input over here or the EMF is basically inputting over here. यहाँ से हम लोग EMF input कर रहे हैं. So these due to which the coil will have some magnetic field. As don't forget that this is going to be an AC source. Okay, so this is going to be an AC source. So the magnetic field will produce as because we have a coil over here. So this magnetic field will magnetize. This magnetic field will magnetize this iron core. Now, from there, this magnetized iron core is going to cut down the magnetic field of this iron coil in the secondary portion of this transformer. Okay, so अब होता ये है कि जब ये मैग्नेटाइज हो जाता है तो ये इनकी जो मैग्नेटिक फील्ड है वो इस आयरन कॉइल को कट डाउन करेगी. They will try to cut down or interact with the secondary coil, due to which, as you guys know from the induced EMF, that when the magnetic field is basically changing with respect to the time, उनका जब EMF आपका with सॉरी मैग्नेटिक फील्ड आपकी रेट चेंज हो रही होती है विद रिस्पेक्ट टू द टाइम, उसका एक इफेक्ट होता है ऑन द सेकेंडरी कॉइल और वहां पे करंट इंड्यूस होना शुरू हो जाती है, EMF इंड्यूस होना शुरू हो जाता है. दिस इज द मैकेनिज्म बिहाइंड द ट्रांसफॉर्मर्स. ओके, सो what happened over here? First, we have provided the AC source. हमने AC source provide किया to the primary coil. जिसने due to that, basically due to the magnetic field produced by the AC, it basically magnetized your iron core. Now, जो आयरन को मैग्नेटाइज हो गया है अब उसकी वजह से उसमें मैग्नेटिक फील्ड प्रोड्यूस होगी और वो इंटरेक्ट करेगी आपके सेकेंडरी कॉइल के साथ. And the rate of change of this magnetic field that occurs in the secondary coil will result in the induction of EMF in the secondary coil. Now, the thing is that this EMF is continuously changing because why this EMF is basically changing. The reason behind is that initially we were using the AC alternating current. So this EMF is again going to change continuously due to the alternating source. Okay, but remember one thing: the frequency across this system will remain same. Okay, you are not going to change the frequency. Frequency will always remain same. Like for example, if I'm having the this portion is, let's suppose, representing the primary portion of the transformer, and this portion is representing the secondary portion of a transformer. Okay, means I'm just talking about the primary portion. The secondary portion of the transformer means I'm talking about the coils, the number of coils in the primary transformer. So let's suppose it is a type of a transformer in which we have the in the primary coil we have the total EMF is 18 kilovolt and the frequency is 50 hertz. Afterward, when it enters to the secondary coil, now this is the step up transformer. So let's suppose the EMF improved from 18 to 500 kilovolts, but still the frequency would remain same. So no one is allowed to change the frequency in the system. Okay, the frequency basically आपकी जो frequency होती है, when you talk about the frequency जो होती है for the electricity we basically kept it 50 hertz. इसके पीछे रीजन ये है कि मोस्टली हमारे जो इक्विपमेंट्स होते हैं वो डिजाइन ही 50 हर्ट्ज के लिहाज से होते हैं. सो हमारा इक्विपमेंट जो डिजाइन है वो भी 50 हर्ट्ज के लिहाज से होता है और जो हमारा जनरेटर रन हो रहा होता है वो भी 50 हर्ट्ज पे रन हो रहा होता है. तो फर्स्ट ऑफ ऑल वी हैव टू मेक श्योर दैट कि हमारी फ्रिक्वेंसी सेम हो, हमारी फेजेस सेम हो, तो हम लोग अपनी करंट को जो है आगे अपने एरियाज तक फॉरवर्ड कर सकते हैं. तो दिस इज द मैकेनिज्म बिहाइंड द ट्रांसफार्मर. ओके, नाउ let's talk about the efficiency. अच्छा बेटा, transformers basically there is no such a case like an ideal case, लेकिन हम लोग अपनी उसके लिए अपनी convenience के लिए we basically call that we have some ideal cases, and for this we consider that that we have the 100% efficiency. And here we are saying that the power input is going to be equal to the power output. Ab beta, power input is actually the number of basically the power of your primary coil, and power output is going to be power across your secondary coil. In real, the efficiency is always less than 100%. The power input is always equals to heat plus power output because we are basically some of the heat basically dissipate हो रही होती है. The reason behind is that आपकी dissipate क्यों हो रही होती है heat, because whenever you applied any energy, so आपको कभी भी एक पावर से एक यूनिट से दूसरी यूनिट पे when you are converting a thing, आपको 100% एनर्जी नहीं अवेल होती. सिमिलरली ये उसमें लॉसेस होते हैं जस्ट बिकॉज ऑफ द रेजिस्टेंस एंड सम अदर थिंग्स, और उनकी वजह से लॉसेस होते हैं वो हीट फॉर्म में लॉस होते हैं. सिमिलरली एक स्मॉल एग्जांपल लेते हैं लाइक आवर मोबाइल चार्जर. सो मोबाइल चार्जर्स जो होते हैं, एडाप्टर्स जो होते हैं, दे आर आल्सो एन एग्जांपल ऑफ द ट्रांसफार्मर्स. वो स्टेप डाउन ट्रांसफार्मर होते हैं. दे बेसिकली यूज टू स्टेप डाउन 220 or 230 volts into the 5 volts. Okay, So अब वहाँ पे क्या होता है, after some word, after using basically when you plug in your adapter into the switch, into the socket, so after 1 hour or 15 to 20 minutes, you guys can find it out easily that it's getting basically it's getting warm. The reason behind is that why it is dissipate the heat into the atmosphere is because of the resistance inside the our adapter. So ये ध्यान में रखना है कि हमेशा heat emit होती है, dissipate होती है from the system because of the wires and because of the resistance in the system. ठीक है, तो आप लोगों ने हमेशा adapters को देखा होगा, after some word वो heat up होने लगता है. So again, the actual the real transformers equation is this, that PP, that is a primary power, is going to be equal to the loss of the heat plus the secondary power. Okay, so one more important thing, the power of the transformer always remains constant. This is very important thing. Okay, just you have to remember this thing for whenever you get any question related to the transformer. आपने दो चीजें याद रखनी, that your power is always remains same, or it always remains constant. Second thing, frequency remains same. Frequency will never change. ये दो चीजें आपने हमेशा याद रखनी. Now let's talk about the type of transformer. Basically, there are two types of transformer. Number one is step up transformer, the other is the step down transformer. So what is meant by step up transformer? It means that it's going to, the primary voltage across this step up transformer is going to be lesser, and the secondary EMF across the transformer is going to be greater. Okay, so I think it would be good to represent with the arrow. So it's going to be greater and it's going to be less. Okay. Now, when you talk about the current IP is going to be greater over here, and IS over here is going to be the less. ठीक है, क्योंकि मैंने आपको पहले ही बताया था that the current and the voltages would basically they will reverse to each other. They are going to be in the reciprocal manner to each another. Similarly, when you talk about the number of turns, so the number of turns in your primary coil is going to be lesser, while the number of turns in your secondary coil is going to be greater. Okay, so आपको ये याद रखना है कि step of transformer में you have to talk about three things. Number one, number of turns. Number two, you have to talk about the EMFs. Number three is the current. So the number of turns in the secondary coil is going to be greater than the primary coil. Similarly, EMF in the secondary coil is greater than the EMF in the primary coil, and the amount of the current in the secondary coil is less than the amount of current in the primary coil. Now, when you talk about the step down transformer, so step down transformer is actually, you can say that it's reciprocal to the step up transformer. उसका बिल्कुल opposite हो जाता है. So over here, the number of turns in the primary coil is more as compared to the number of turns in the secondary coil. Okay. Now let's talk about the EMF. So EMF across the primary coil is more as compared to the EMF across your secondary coil. Okay. And when you talk about the current, so the current across the primary coil is lesser as compared to the current across your, sorry, as the current across your secondary. Okay, so the current across the secondary coil is more. Okay, now what I explained over here is given there. Actually, second thing is that how you are going to represent this. Just look at over here, the number of coils over here in the primary coil. आप देख सकते हो this portion. यहाँ पे आप देख सकते हैं नंबर ऑफ कॉइल्स बहुत कम है, लेकिन जब आप बात करते हैं सेकेंडरी कॉइल्स के, तो नंबर ऑफ कॉइल्स या नंबर ऑफ टर्न्स बहुत ज्यादा है, दे आर अ लॉट. सो यहाँ से मैं वो फर्स्ट कॉन्सेप्ट क्लियर हो गया दैट हियर वी आर गोइंग टू टॉक अबाउट द नंबर ऑफ टर्न्स. सिंबॉलिकली आपने इसको रिप्रेजेंट कैसे करना है. सो यू हैव टू मेक टू कॉइल्स. ठीक है, the number of turns across your primary coil should be lesser than the number of coils in your secondary portion. Okay, and among these two you have to make a vertical line. Okay, so this is the symbolic representation for the transformer. ओके, सो जो चीजें हमने ऊपर एक्सप्लेन की थी वो सारी की सारी यहाँ पे एक्सप्लेन की गई है. जैसे वी एस voltage across the secondary coil is greater than the voltage across the primary coil. Number of turns in the secondary coil is greater than the number of turns in the primary coil, and this current across the secondary coil is less than the current in the primary coil. So what are the uses of the step up transformer, and where basically we use these? So these are used in the power plants, X-ray machine, microwaves, etc. Again, Again, you have to keep this in mind that the power across the primary coil and the secondary coil will always remain same or constant. ठीक है, आपके पास पावर नहीं चेंज, पावर हमेशा सेम रहेगी. ओके, अब बेटा स्टेप ऑफ ट्रांसफार्मर हम यूज क्यों करते हैं? लाइक व्हेन यू टॉक अबाउट द ट्रांसफार्मर्स, पावर प्लांट्स हम क्यों यूज करते हैं? The thing is that if we are increasing, when you talk about the power plants, as we said earlier, that it's going to be P is equals to IV, and the power will remain constant. ये constant रहेगा, ये change नहीं होगा. Not going to be changed. Now, if I want to increase the EMF, so I have to reduce this current. मुझे current कम करनी पड़ेगी. If I'm reducing the current, so the effect of the reducing the current will also results in the reducing the our it will also help us in reducing the uh, resistance. Now, वो कहाँ से हमें पता चलता है? So, okay, so as we are increasing the EMF over here and we are decreasing the current, so what would be the effect of the current? If you're reducing the amount of a current in a wire, आपके पास एक वायर है, you are basically reducing the amount of a current. It means that you are basically limiting the amount of the electrons to pass from through the wire. अब जब electrons कम वायर से move करेंगे, so if we have any resistance over here, तो resistance का act जो होगा, उस पे effect जो होगा, वो भी कम हो जाएगा. So generally आपकी resistance कम हो जाएगी. So why we basically step up the voltage in a power plant? The reason behind is that we wanted to supply a lot of load by using a small amount of electrons or the current. ठीक है, हम ज्यादा लोड को मूव करना चाहते हैं कम लोड के साथ, सॉरी ज्यादा लोड को मूव करना चाहते हैं विद अ कम चार्ज, हमारे पास कम चार्ज मूव करे, और उससे ये होगा ड्यू टू विच हमारे पास जब तक वो आपके पास दूसरे एंड पे जब तक सोर्स पहुंचेगा, करंट पहुंचेगी, तो उसमें लॉसेस कम होंगे. लॉसेस कम होने की वजह से आपके पास लाइक इफ यू आर सप्लाइंग, लेट्स सपोज आप 221 मेगावाट सप्लाई कर रहे हो, तो एट द एंड जब वो आपके एरिया तक पहुंचेगा, तो देयर इज अ चांस कि उसमें 0.1 मेगावाट या 0.2 मेगावाट उसमें लॉस आ जाएगी पावर में. लेकिन अगर आप स्टेप अप नहीं करते हो और आप उसी को फ्लो करते हो, तो इट मीन्स दैट यू आर एक्चुअली अलाउइंग दिस 221 मेगावाट जो आपका लोड था, आपकी जो पावर थी, आप उसको अलाउ करें तो स्मॉल स्मॉल चंक्स में मूव करे. जब बेटा वो स्मॉल स्मॉल चंक्स में मूव करेगा, सो उसके लिए रास्ते में उसको मीन्स इट यू आर बेसिकली इंक्रीजिंग द नंबर ऑफ इलेक्ट्रॉन्स, आप करंट की अमाउंट को इंक्रीज करो. तो उससे ये होगा कि उसके लिए रास्ते में देयर इज गोइंग टू बी इन अ वायर, देयर इज गोइंग टू बी अ लॉट ऑफ रेजिस्टेंस. अब उसका रास्ता रोकेगी करंट. ठीक है, तो फॉर कंट्रोलिंग दिस थिंग व्हाट वी डू जनरली, वी बेसिकली हम क्या करते हैं, वी बेसिकली इंक्रीज द ईएमएफ. हम ईएमएफ इंक्रीज करते हैं ड्यू टू व्हिच आवर करंट विल ड्रॉप. ठीक है, हमारी करंट ड्रॉप हो जाती है, एंड हम लोग स्मॉल अ लॉट ऑफ जो हमारे पास लोड होता है, हमारे पास पावर होती है, वो हमारे पास स्मॉल जो हमारे पास जो मिनिमम अमाउंट ऑफ करंट रह जाती है, वो लेके मूव करती है. तो इट मीन्स दैट देयर इज गोइंग टू बी नो ट्रैफिक फॉर द करंट इन अ वायर. ठीक है, आपने ट्रैफिक कम कर दी, यू जस्ट रिड्यूस द करंट, आपने इलेक्ट्रॉन्स कम कर दिए. ठीक है, सो दैट्स वेयर आप भी बेसिकली व्हाट यू गाइस डूइंग ओवर हियर, यू आर बेसिकली एनर्जाइजिंग द इलेक्ट्रॉन मोर. आप इलेक्ट्रॉन को इतना एनर्जाइज कर रहे हो कि वो ज्यादा पावर क्रॉस कर सकते. नाउ X-ray machine में भी we need a lot of basically we have to improve the EMF. हम EMF improve करेंगे, after then हम लोग किसी भी एक इलेक्ट्रॉन को एनर्जाइज कर सकेंगे फॉर बेसिकली फॉर गेटिंग अ प्रॉपर इमेज ऑफ एक्सरे. सिमिलरली गोस इन दी माइक्रोवेव. माइक्रोवेव में भी यही होता है कि आपके माइक्रोवेव ओवन के बैक साइड पे लिखा होता है दैट इट्स गोइंग टू ऑपरेट एट दिस वोल्टेज. तो हम क्या करते हैं, there is a step transformer inside the microwave which is basically converting your 220 volts. It is actually converting your 220 or 230 volts into roughly mostly the microwaves are roughly of 400 volts. ठीक है, इसके होते हैं, इससे ज्यादा होते हैं, आई थिंक 6 भी होते हैं, 800 भी होते हैं. सो दैट्स अ वे, बेसिकली दैट्स अ फिनोमेना बिहाइंड द स्टेप ऑफ ट्रांसफॉर्मर जब वी नीड टू इंक्रीज द EMF. Okay, now let's talk about the step down transformer. So बेटा step down transformer में क्या होता है, that you have a lot of primary coils but you have a lesser secondary coil. आपके पास सिंबॉलिक इमेज जो है वो इसी तरीके से रिवर्स हो जाएगी. ठीक है, जैसा पहले था, प्राइमरी कॉइल ज्यादा हो जाएंगे, सेकेंडरी कॉइल इज गोइंग टू बी लेसर. नाउ स्टेप डाउन ट्रांसफार्मर जो कि हम पहले डिस्कस कर चुके हैं, दैट इज गोइंग टू हैव the EMF across your primary coil is more as compared to EMF across your secondary coil. Similarly, the number of turns in the primary coil is more as compared to the secondary coil. While when you talk about the current across the secondary coil is more as compared to the current across the primary coil. Now, what is happening over here? Look at over here, P is equals to IV. Now, in the step down transformer, we are actually increasing this current due to which the EMF is reducing, okay, while keeping the power constant. We are not going to change the value of the power. So हमने current को improve किया, हमारे पास EMF या voltages ड्रॉप हो गई। इसकी यूजेस क्या है? चार्जर्स हो गए, आपके डोमेस्टिक ट्रांसफार्मर्स हो गए, जो हमारे घरों के बाहर ट्रांसफार्मर होते हैं, दे आर मोस्टली दे आर नॉट मोस्टली दे आर एक्चुअली दे आर बेसिकली अ स्टेप डाउन ट्रांसफार्मर। आपके पास जितनी भी पावर ट्रांसमिशन लाइंस होती हैं आफ्टर दैट स्पेसिफिक ट्रांसफार्मर, जो कि आप लोगों के घरों के बाहर है, वो जो होते हैं वो स्टेप डाउन होते हैं, ठीक है, वेल्डिंग मशीन हो गई एक्सेट्रा। अगेन द प्राइमरी एंड सेकेंडरी कॉइल्स पावर रिमेन्स सेम, ये ध्यान में रखना है, इट इज वेरी इंपॉर्टेंट, ओके। So now, students, just look at this diagram. Basically, this is the step down transform. Now, over here, the question is that how basically when you talk about the transformer, अब इसमें से current pass हो रही है, it has some resistance. अब वो भी heat dissipate आपके पास dissipate कर रहा है. So it's all again dissipate the heat. अब वो जो heat dissipate हो रही है, so वो किस तरीके से remove हो रही है? So these are the fins. Here we have a fins. यहाँ से ये dissipate होती है. Basically, when you talk about the transformer, inside the transformer we have oils. There are different types of the oil. हम लोग इसके अंदर basically we fill it with the oils, and all our equipment is basically immersed in that oil. अब होता ये है कि when the equipment get heated, वो heat transfer कर देता है to the oil. From that oil, the heat is transferred to these iron fins. ये जो आपके पास इस तरह की एक elongated parts से है ना, इनमें heat आ जाए. So when the air flows through these fins, तो वो heat absorb कर लेती है air, ठीक है? So this is the example of the step down transformer. Now, so let's talk about the equation of the transformer. So generally, the equation of the transformer is number of turns in a primary coil upon the number of turns in the secondary coil is going to equal to the EMF across the primary coil upon EMF across the secondary coil. So the efficiency is equals to Vs upon Vp times 100%. Or in other words, you guys can go with this also, that instead of a power, you have to write it down as N. Okay, that is number of turns across the primary and the secondary coil. आप number of turns की basis पे भी अपना efficiency define कर सकते हो. Okay, so just give me a minute. So this is like this. Okay, so it's a number of turns in the primary and the secondary. Okay, okay. So आपको ये पता होना चाहिए कि व्हाट इज दी बेसिकली आपने किस तरीके से इस चीज़ों को एक्सप्लेन करना है. एफिशिएंसी आप इसकी निकाल सकते हो विद नॉट जस्ट विद द हेल्प ऑफ दी योर voltages, but you can also find out the efficiency with the help of the number of turns. ठीक है. Now when you talk about the efficiency, so आप लोगों को याद होना रहना चाहिए that every time whenever we're going to talk about the efficiency is actually equals to always equal to output upon input times 100%. Okay. Now here the output is Vs and the input is Vp. Similarly, when you talk about the number of turns, so Ns is the output and the Np is the input. Okay. Now, why is step transformer used by the power companies or the power plants? So we need to adjust. Now we need to keep the power constant. So when we increase the voltage, this will help us in the reduction of the current. So the resistance also reduces. Okay. Now this over here, what we are seeing that if you are increasing the voltages, हमारे पास voltages rise हो रही हैं, तो उसकी वजह से हमारे पास power, हमारे पास resistance reduce होती है. इसके पीछे reason वही आ जाता है that P is equals to IV. Okay. Now, if I'm increasing the voltages over here, so my current will get decreases. Okay, with the time, इसमें reduction आएगी because we are going to keep our power constant. अगर current reduce हो रही है, due to which our resistor will also get basically it also is going to reduce. Okay, so to अब हम लोग resistance को क्यों reduce करें, उसके पीछे reason है ताकि we basically want to reduce the losses. ठीक है. So to reduce the losses, we increase the voltage, will result in the reduction of the current and the resistance. So that's the main aim of the step up transformer, and it's a very important question. So sometime it comes in your papers also. So ये आपने define करना है why the companies and the power plants are basically using this type of transformer. Okay. Now, what happened when the voltage decreases? अब क्या होता है? So first thing is that the current increases, second the resistance increases, and as the resistance increases, so the increase there is going to be increase in the current loss. ठीक है? So now over here, ये equation ये आपको सिर्फ समझाने के लिए that we have another type of equation for the power. Okay? So this is the explanation of the transformer. अच्छा बेटा एक और चीज. When you talk about the step up and step down transformer, just I'm going to make a symbolic representation over here. I'm representing over here. So this is a transformer. Okay. So you guys can say it that this is the step up transformer. Okay. Step up transformer. When you guys move from left to right. अगर left से right पे जाते हो, so it's a step up transformer. But when you guys move from right to left, it will become step down. Okay. So over here, I just want to explain this thing you that uh, that if you connect it reversed, if you have a step up transformer and if you connect it in a reversed way, like आपका जो यहाँ पे आपका primary आपके पास let's suppose this is your primary portion, आपके पास यहाँ पे VP है and over here you are getting your VS. अगर by mistaken आप लोगों ने by mistake और due to some need of the application आपने क्या किया है कि that आपने यहाँ पे input दे दिया, you just give an input over this side and over here you will get the output on the other side, so वो step down हो जाएगा. It means that they can be reversed. आपका step up transformer can easily be reversed into the step down just by reversing the source of the current. आप source of current reverse करोगे, आपके पास आपका transformer अपनी condition change करेगा, step up से step down हो जाएगा. Now there's a question. Okay, in this question they are saying that the transformer has a 4800 turns on the primary coil which is connected with the main supply of 30 volts, and output of a 5 volt is used to operate the bell. Calculate the number of turns needed on the secondary coil. So for this the formula is NP upon NS is equals to VP upon VS. Okay, it doesn't matter आप NS को कभी लिख सकते हो and means आप इसको rotate भी कर सकते हो, उससे कोई फर्क. So let's solve it. So over here this is the primary turns. So this is our NP and this is our VP. Now this is our VS and we don't know the value of NS. NS is unknown for us. So I'm just arranging this equation for NS. So NS is going to become VS upon VP. VS upon VP times NP. Okay, so the NS will become VS is 5 volt 5 times 4800 upon it's 230. So we have to solve this thing and what we get. So our answer for this question is 104.34 tons. So 104.34 tons. First thing is that our turns can't be in a decimal form, so we have to round it off. Second thing is that in a physics, the examiner basically expecting that you guys should have to give the answer into two significant figures. If you are not going to give the answer into two significant figures, then he or she will deduct your marks. So we have to round off our answer into two significant figures. So the answer for basically for this question, our answer is going to be 100 tons. Okay, मुझे सिर्फ two significant figures में आंसर चाहिए. So after these two figures, I'm going to round off these figures. Okay, मैं इसके बाद सारे figures को round off कर लूँगा. So as the number over here is 4, so it's going to be round off into the form of a 0. अगर मेरा बच्चा ये figure this number अगर ये 5 होता या greater than 5 होता तो ये 1 round off हो जाता. So this is the answer for this question. we were discussing about the transformers, and in that topic, I just find out that you guys were struggling that we have to place the transformers and we have to place the generators. Okay, so it is a very common issue. So that for that, I'm just repeating the topic which we discussed back in grade nines. That was the hydroelectric power plants. Okay, now students, ये जो topic था that is related to your the topic in which we discussed the GP and P and kinetic energy, where we discuss the gravitational potential energy and the kinetic energy. Okay, हम लोगों ने यहाँ पे वहाँ पे we discussed that topic. Now, सबसे पहले let's talk about the conservation of energy. As you guys see over here, okay, but when you talk about the simple hydroelectric power plants, we have few things over here. Number one is our reservoir. The reservoir is a place where we basically place a water, store the water for a shorter time. Then we allow the water to move from that height to the turbine. Now, this is the turbine. Okay. Now, okay, better this pipe is actually for you guys, you can call it a pipe, but it's generally what we call it a penstock. Okay, now this is the penstock, and you guys can call it a pipe because ये आप लोगों की इतना आप लोगों के लिए important नहीं है. So after the water enters into the turbine, so water first initially water is in the reservoir, then the water moves into this penstock. Okay, then it runs the turbine. The turbines also rotate. Rotation की वजह से this shaft, this one over here, this is representing the shaft. Okay, this is representing the shaft, and this shaft will help us out to, just give me a minute. Okay, this shaft will help us out to rotate the generator. Okay, and inside the generator, the electricity is produced. Okay, now from the electricity which is produced inside the generator is moved to the step-up transformer, where we increase the voltages or the EMF of the current or of the power, and then from the transformer. Excuse me, students, please maintain the silence. Okay, from the transformer, the electricity enters into the grid, and from the grid it goes to the city. And after, and in the cities, when the current enters into your own township, आप लोगों की simple towns में enter होती है. So before that, just give me a minute. Okay, now from this, when it enters to your town, आपकी town में जब this current enters, it again enters into the transformer. Okay, so just give me a minute. It again enters into the transformer, which is the step down transformer. Okay, so over here I just explained the whole process, that how the electricity comes to your homes. Okay, now when you talk about the law of conservation of energy, just over here, look at there. This is the ground level, and the water over here is at some height. Okay, so this is some height over here. So जो water reservoir में है, the water which is in the reservoir, it's going to have some gravitational potential energy. So मेरा बच्चा, हम लोग जो law of conservation के लिहाज से पढ़ते थे, we said that the gravitational potential energy is converting into the kinetic energy of water. ठीक है, first it's going to the kinetic energy of water, then this kinetic energy of water helps to turn the turbine. So this is going to be converted into the kinetic energy of turbine, and then this kinetic energy of turbine basically produce the electricity. So beta just over here, आप लोगों ने, you have to keep this in mind that अच्छा बेटा, these steps are very important. The reason behind is that they sometimes give you the question related to these steps in P2. Okay.
सर हमें ये लिखना है, सब हम लिखें.
No need to write it down because we discussed this thing back in grade 9. हमने तब लिखा था. Okay. And along with that, I'm also making a video. So if you guys have any queries related to any topic, आप लोग YouTube से देख सकोगे. ठीक है? I will upload this video, inshallah after this class. Okay?
सर मुझे एक सवाल है कि
Yes.
मतलब घरों में इलेक्ट्रिसिटी जाने के बाद कैसे स्टेप डाउन ट्रांसफार्मर यूज हो रहा है?
बेटा सिटी में अभी मैंने करंट भेजी है. अब स्टेप डाउन ट्रांसफार्मर से जब करंट निकलती है, देन दिस करंट विल just wait, where's my cursor? Okay, now from there this electricity will enter into your houses, in your house. Okay, okay. फिर आपके घरों में enter होती है, in your homes and houses. Okay, okay.
मतलब जो हम लोग मोबाइल में हमारी इलेक्ट्रिक मोबाइल जैसा हमारा यूज हो रहा है ऐसे, तो वो स्टेप डाउन ट्रांसफार्मर.
Yes, that's a step down transformer. Even जो आप लोगों के घरों के बाहर जो बड़े बड़े ट्रांसफॉर्मर्स लगे हैं ना, the enormous bodies of the transformers, they are also step down transformers. Okay. अब
सर,
yes, yes.
जो स्ट्रीट ट्रांसफार्मर्स होते हैं वो स्टेप अप होते हैं, स्टेप डाउन होते हैं?
Street transformers are step down transformer.
ओके.
The transformer which are in the power plant, ठीक है, they
सर
are
तो
step
फिर
up
कैसे
transformer.
जो स्टेप डाउन ट्रांसफार्मर्स होते हैं वो तो एकदम आउटकम मतलब होते हैं, तो अगर जो है वो स्ट्रीट पर लगे होंगे तो मतलब घरों में इलेक्ट्रिसिटी जाने से पहले वो लगे हुए होते हैं, तो कैसे वो
बिल्कुल.
स्टेप डाउन ट्रांसफार्मर्स है?
बेटा देखो, the thing is that the voltages which we are getting from the line, ठीक है, हमें लाइन से कुछ voltages मिल रही हैं, ठीक है, we have to step down because our most of the equipments are basically 220 volts designed. Okay, हम उनकी जो rated होती है they are 220 volts. Okay, और 230 volts. Okay, so हम लोगों ने जैसे अगर आपको याद हो that by if we increase the if we decrease the secondary coils in a transformer, तो हमारे पास वो ट्रांसफॉर्मर स्टेप डाउन ट्रांसफॉर्मर बन जाता है. सो वी यूज द सेम मैकेनिज्म. ओके, जो हम लोग पहले मैकेनिज्म यूज कर रहे थे. ठीक है, स्टेप अप में क्या होता था, दैट इन स्टेप अप योर प्राइमरी कॉइल इज लेसर देन योर सेकेंडरी कॉइल, while in your step down your primary coil are more as compared to your secondary coils turns. ठीक है ना, उसमें टर्न्स ज्यादा हो जाते हैं. गॉट इट? अभी से आप गॉट इट और नॉट?
सही है, तो हम लोग मतलब ऐसे देखकर बताएंगे कैसे कि उस स्टेप अप है कि स्टेप डाउन है, मतलब जैसे हमने उसका पढ़ा था पिछले क्लास में, तो हमने तो उसका मतलब ऐसे इंटरनल पढ़ा था कि इसकी स्प्रिंग ऐसी है, लेकिन बाहर से देखकर हम कैसे बताएंगे कि स्टेप अप है स्टेप डाउन?
तो इसमें मेरे बच्चे आपने बाहर से देख के बताना क्यों है?
ऐसा
ठीक है,
सवाल नहीं आ सकता
नहीं आ सकता,
सर,
कभी भी नहीं
फिजिक्स
आ
में
सकता.
कुछ भी आ सकता है, आपको नहीं पता?
मुझे नहीं पता. आई थिंक दैट आई एम अनअवेयर ऑफ द टॉपिक्स
नहीं,
रिलेटेड टू द
आपको
फिजिक्स.
आपको पता है लेकिन
ओके, नहीं नहीं, ऐसा कोई क्वेश्चन आपके उसमें नहीं आएगा. जस्ट आप इस चीज के लिहाज से यू हैव टू बी I'm basically assuring you that you will never get a question related to that either the transfer like if they give you a picture and they ask that whether it's a step up or step down. आपको ऐसा ये लोग कभी भी they will never give you a question like this, because if they are not mentioning out the number of the turns inside the transformer, so आप कैसे कह सकते either it's a step up or step down. और इसकी बेसिस पे फॉर दैट आई जस्ट सेलेक्टेड वन ऑफ द क्वेश्चन फॉर द वर्कशीट. उसमें वी विल डिस्कस ऑन इट अलॉट. ओके, उसमें बड़ा मजा आएगा. यू गाइस विल एंजॉय दैट टॉपिक अलॉट. अच्छा, अब मेरा बच्चा जस्ट लुक एट ओवर हियर. देखो, हम लोगों ने लास्ट टॉपिक जो हम लोग डिस्कस करते दैट वाज अ ट्रांसफार्मर, एंड बिफोर दैट वी डिस्कस द जनरेटर. So just for that, अब आप लोगों ने you have to get this in mind that first we have a reservoir, then we have the turbine. After the turbine, we have the generator. After the generator, we are going to have a transformer. ठीक है ना? Then from a transformer, the electricity enters into the grid, and from the grid it moves to the cities. Okay, is that clear? अब आप लोगों को मैं कुछ एक वीडियो शो करना चाहता हूँ. Okay, so now I'm going to show you a video. In this video, okay, now better, what you guys are seeing now, this is the reservoir. Okay, shh, keep quiet. Just keep quiet now. Okay, now students, now what you are seeing now, this is the reservoir. Okay, reservoir is the place where we store our water. Now, just look at this. This is the one side of view of the reservoir. Now, this is the whole length of the reservoir. I'm showing you the reservoir on which basically I'm working. Basically on which power plant I'm working. मैं आपको वो दिखा रहा हूँ. So, Okay, now beta, this is a combination of the turbine and a generator. Can you see my circle? My mouse cursor आप देख पा रहे हो? My mouse cursor. Can you see the mouse cursor? Students, can you see my mouse cursor?
यस सर नजर आ रहा है.
Okay, that's good. बेटा ये जो मैं नीचे जिस एरिया पे I'm pointing out this red portion, this portion is known as turbine. Okay, or along this turbine, as you can see the bluish nozzles. These nozzles are used to target a water towards the towards the turbine. Okay, just above this turbine we have a shaft, and above this there's another disc. This disc, ये जो बड़ी वाली disc है, this red disc. This disc is actually a generator in which the electricity is produced. Okay, is that clear? So अब आप लोगों को मैंने क्या बताया that initially we have a reservoir. Now from the reservoir the water enters into the penstock or the pipe, जो pipe होता है. So after that I'm going to show you the picture of a pipe. This is the pipe in which the water basically comes from the dam into the power plant. ये वो पाइप होता है जिसके जरिए पानी इंटर होता है. इसका हम लोग कहते हैं, we call it MIV, main inlet valve. Okay, so this is the pipe from where the water enters into the plant. Okay, यहाँ से टरबाइन के अंदर इंटर होता है पानी. ठीक है, just look at the pressure of this the water inside the pipe. क्योंकि मैंने आपको क्या कहा, वो एक हाइट एक आपका जो reservoir है, it is at some height. ठीक है, so due to that height the water is coming with some pressure. Just look at the pressure of the water. The pressure of water is approximating 9 megapascal. Okay, इतने प्रेशर के साथ वाटर आता है. Boys, keep quiet. Along with that, I'm going to explain you one more thing over here. Now, this is that specific pipe जो कि मैंने आपसे डिस्कस किया था. That is a main inlet valve जिसे हमारे पास पानी टरबाइन में इंटर होता है. Now, do you guys remember in grade? So, अच्छा, beta, in grade 10 we discussed about the condensation. So, can anyone explain me what is the condensation? Hmm? Do anyone remember? Yes. What happened to the liquid? मुझे liquid को कुछ होते हुए सुनाई दिया है. What happened to the
गैस टू
liquid?
लिक्विड होता है. गैस टू
Gas
लिक्विड होता है सर.
gas get liquefied. Yes, it's not a, it's basically a
gas to liquid.
gas. Yes, gas to liquid. Basically, what
Sir,
happened in the condens?
sir,
Yes, and
condensation is the change of state from gas to liquid when, due to kinetic energy, the particles comes close to each other. From chaotic movement, they become irregular movement. Sir, सही है.
better you can't say that it's from the purity movement to the irregular movement. When the basically when you are changing the phase from the vapors to the liquid, you are basically giving it a proper regular motion. Okay, so that's good, excellent. But let I explain this thing again. When you talk about the condensation, so what is a condensation? Whenever the water vapors come in contact with the cooled surface, they get they become droplets. Okay, from the vapor they become the droplets. That process is known as condensation. Means that they just lose their kinetic energy, or you can say that they just lose their some of the energy due to which they got their kinetic energy become lesser, and they try to get assemble with one another, or they try to get collide with one another and keep that bond strong, and due to which we they become a proper droplet. Okay, now
Okay, sir.
now over here, I'm just showing you the condensation also. Just look at this pipe, okay? मेरा बच्चा, this pipe is not leak at all. It is not leak at all because the pressure inside this pipe is 9 megapascal, means 9,000 pascal. एक बहुत ज्यादा प्रेशर है. If it leaked, तो वहां से पानी इस तरीके से निकल रहा होता ना कि like for example if I'm going to place any harder thing like an iron in front of it, वो उसके अंदर भी होल कर सकता है. इतना प्रेशर होता है 9 megapascal. So just look at over here. As our power plant is having some humidity, हर जगह पे humidity होती है. Now we are inside a mountain. हम mountain के अंदर, so the amount of the humidity over here is more. So just look at there. When the humid air come in contact with this pipe, as the water inside this pipe is roughly 12 to 14 degrees Celsius, because we are near to the Naran area, and you know that in the Naran the ice is melting. Okay, glaciers melt कर रहे हैं, the ice is melting, due to which the temperature of the water over here is very less. So just look at over here, the humid air that become condensed, और ये देखिए ये सारी condensed air है, ठीक है, जो कि water की form में इसके ऊपर लग
State.
गई है, ठीक है. Yes.
Yes, sir. Please continue.
Okay, now beta, this is the area. ये जो आपको, you guys can see the door over here. Inside this door is a turbine. Okay, the turbine basically runs with the help of a water, and due to which our you can say that our basically the turbine runs due to the water, and due to which the generator produce the electricity or induce the electricity. Now this is the shaft of a turbine. Just look at the rotation of the shaft of the turbine. Okay, now it's rotating. ये rotate करिए मेरा बच्चा, इसका ऊपर वाला जो हिस्सा है ना, the upper portion is directly connected to the generator. और generator में मेरा बच्चा वो वाला concept है जो आप लोगों को मैंने बताया था, that in a generator ये जो coil, ये जो basically ये shaft घूम रही है ना बेटा, इसके ऊपर we connected a coil. Okay, and around it we place the iron, we place the magnet, ठीक है. Now when the coil rotates, उससे क्या होता है, it basically interact with the magnetic field of a generator, और उसकी वजह से हमारे पास we produce a current, ठीक है, इंड्यूस होती है, ईएमएफ इंड्यूस्ड होती है, ठीक है. सो अब ये देखो, ये शाफ्ट जो है, ये बेसिकली आप लोगों को याद होगा, मैं हमेशा अपने हाथ से कॉइल को रोटेट करता था लाइक दिस. सो एक्चुअली दिस इज व्हाट इज डूइंग, इट इज रोटेटिंग द कॉइल लाइक दिस इन अ सिंगल रोटेशन. ओके, ठीक है, तो ये रोटेट कर रहा है. सो now this is the shaft which is actually rotating the coil इसके ऊपर वाले रूम में है. Okay, now as you guys can see over here, there we have some disc over here जिसको मैंने cursor से point out कर रहा हूँ. These discs are the nozzle from where the water enters into the turbine. Okay, now बेटा ये जो रूम है, this room is actually a generator room, ठीक है. Now the thing is that we are not allowed to enter in this room because it is energized room, and the electricity which is produced by this generator is 18,000 volts. 18,000 volts, ठीक है. आपके घर में जो बिजली आती है ना, वो 220 वोल्ट होती है. 220 वोल्ट से कितना गंदा झटका लगता है. ये 18,000 वोल्ट है. Even we are not allowed to pass through pass in front of this area because इसकी इतनी ज्यादा heavy magnetic field है कि ये हमें attract कर सकता है वॉल के साथ भी. So whenever we entered into this area, हम लोगों के अपने specific uniform होते हैं. We used to wear that uniform. So this is the room where we have a generator. Okay. Now, अब मेरे बच्चे just look at these pipes. ये pipes क्या हैं? What do you guys think? What it would be? ये 3 pipes हैं. इन पे कलर भी है, blue, yellow and red. Any guesses? Any guesses?
मैं नहीं बोल रहा.
बोलो 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 बेटा, आप लोगों को इसके बारे में नहीं पता होगा. मैं आप लोगों के एक्सप्रेशन पे नोट करना चाहता हूँ जब मैं आप लोगों को बताऊंगा ये है क्या.
सर वेंट्स है.
क्या है?
वेंट्स.
वेंट्स है. अच्छा, सही है. एनीवन एल्स?
सर वाटर इनटेक तो नहीं है.
एनीवन एल्स?
सर फ्यूम्स पास होते होंगे इसमें से.
एनीवन एल्स?
सर ये इलेक्ट्रिसिटी वाइज तो नहीं अंदर भरी हुई इन्होंने.
Excellent. Inside it, it's not a wire. It's not a wire. It's a proper conductor. जैसे लोहे के मोटे-मोटे rods नहीं होते. We actually place 3 rods in these pipes. Okay. Each pipe contain 1 rod. Okay. And आप खुद देखो इसका size इतना बड़ा है तो उसके अंदर rod कितना बड़ा होगा. सही है. So we have 3 rods and basically it's a 3-phase current. So YBR is indicating the phases: red, yellow, blue. Okay. Now, okay. So after this, the current basically enters into the our like just wait. Okay, now wait at this portion. Now this is the end of the turbine. Okay, मेरे बच्चे आप लोगों को जनरेटर में मैंने एक चीज बताई थी that when the generator rotates, it produces the electricity. Now from where this electricity is going to enter into the generator? ये बात sorry into the transformer वो कहाँ से होगी? So we discussed the carbon brushes. Do you guys remember हम लोगों ने carbon brushes की बात की थी. हाँ हाँ students, do you guys remember we discussed the carbon brushes?
सर एक और बार बता देंगे?
मैंने कहा मेरे बच्चा हम लोगों ने when we discussed the generators हम लोगों ने at that time we discussed about the carbon brushes. Do you guys remember?
जी सर जी।
ये जो you guys seeing over here ये जो आपको
सर वो
current
जो
cursor
एसी
जिसके ऊपर
सर
है
वो जो एसी डीसी जनरेटर में वो जो लगे होते हैं।
बिल्कुल जिसके मैंने आप लोगों को लिखवाया था that these carbon brushes are used to transfer the electricity without the tangle of wires. Do you guys remember?
यस सर सर वो लिंक्स के पास वो वाले।
बिल्कुल जो आपके स्लिप रिंग्स के पास होते थे नाउ दिस इज दिस थिंग ये जो आपको नजर आ रही है ना ये बहुत सारी स्क्वायर स्क्वायर चीजें जिसके ऊपर मेरा कर्सर है इस वक्त माउस का दिस इज द कार्बन ब्रश नाउ आई एम शोइंग यू द कार्बन ब्रश की कार्बन ब्रश होते कैसे हैं ओके दिस इज द कार्बन ब्रश एंड द कार्बन ब्रश ओवर हियर इज कनेक्टेड विद ये जो आपको डिस्क नजर आ रही है ना दिस इज द स्लिप रिंग ओके नाउ आफ्टर दैट from there it basically these carbon brushes are collecting the current which is the alternating current जो जिसकी voltage है 18,000 volt now it's entering into the transformer room ये बेटा होता है transformer now this is the step up transformer just look at the size of the step up transformer this is the step up transformer which is actually converting this 18,000 volt into 5 into sorry 18,000 volt it's converting into the 5 lakh volts 500,000 volts okay so it is a step up transformer now this is the step up transformer with that after that the current enters into the grid electric grid में enter होती है and then it reaches to our homes okay so this is the whole mechanism behind the transformers okay मेरा बच्चा एक और चीज a very important thing and you should have to write it down with you guys that I think so it would be good to discuss it now okay so I'm writing over here कुछ समझ आई what I wrote if you reverse the function of a generator it become motors
Sir,
yes
sir, after 8 minutes there will be our break.
okay
8
that's
minutes.
okay and after the 8 minutes we are going to, after your break we are going to start the radioactivity okay now beta just for just remember one thing if you reverse the function of generator अगर generator का function reverse कर लेते हो so it will become the motor इसका क्या मतलब है मेरे बच्चे let's suppose if I am in like over here in a generator what happened in a generator में क्या होता है that with the help of a magnetic field you guys are inducing the एक second just give me a minute I want to make it again okay so what happened in a generator that we have two magnets north and south poles magnet and between them we have a coil now what happened in a generator that if you are going to basically if you are rotating the coil between the north and south pole it will induce the current in a coil generator में ये होता है do you guys remember ठीक है so it means that the current is going out from the generator ठीक है now अगर मैं आप लोगों को आज एक और चीज बताता हूँ like generally the magnet which we are using for the generators are again it's going to be the soft iron okay क्योंकि हम लोगों ने मुतवातर अपनी magnetic field magnetize नहीं करनी because when you talk about the permanent magnet they are weak magnets and the soft magnets can you can stronger the
Sir,
field of
can you
these soft
turn the
magnets.
slide back?
Sorry
Sir, can you turn the slide back above
okay like this
and explain a little, sir?
yeah I'm explaining now
Above.
which one
Sir, above, where you have written GPK electricity.
okay first you want
Yes,
to
sir,
explain
thank you.
this thing okay now beta as you can see over here I'm explaining the first topic first As you can see over here, the water is at some height. This is the height, ठीक है. मैंने आपको क्या कहता है that when you talk about the reservoir, हमारे पास hydroelectric power plants में water क्या होता है, वो at some height होता है. So when the water is coming from the height, so उसकी gravitation potential energy convert होगी. Now when the water enters into this pipe, ठीक है, so the water start running, अब run कर रहा है, so उसकी basically it's converting into the kinetic energy. So that is why ये जो portion है, this portion is representing the reservoir. The kinetic energy of water is representing this pipe. Now, after that, this water is going to rotate the turbine. Turbine को rotate करेगा, and this portion is representing the kinetic energy of a turbine. And after that, the electricity produced in a generator. Okay, so आपको मैं conversion बताया था. It was
And
related
sir,
to the yes,
sir, the motor is the opposite of this. For example, electricity
yes,
converts to kinetic energy of turbine and then of
yes.
yes, है ना?
Yes, yes, it can. अभी मैं आपको इसकी एग्जांपल भी देता हूँ. Just give me a minute. अच्छा बेटा, अब क्या होता है? If you reverse the function of a generator, it becomes motor. Like for example, over here, initially due to the magnetic field, what was happening over here that the coil was rotating and the current was inducing in the coil. ठीक है? Simple. Voltage or EMF was inducing in the coil. Now, like what happened if we just lose the magnetic field, तो क्या होगा, हमारा सिस्टम बंद हो जाएगा. Now I'm explaining you a thing which happened last month in our power plant. I'm talking about the date of yeah, I'm talking about 25 October what happened in our power plant. There was a major breakdown in our power plant. हमारे power plant में एक बहुत major breakdown हुआ था. And at that time we lost all the electricity's connection और हमारा एक blackout हो गया था. ठीक है. Now at that time what happened over there, we have a generator, we don't have a motor. लेकिन हमारा हमारा जो generator था at that time it was starting taking the current from the main grid, मतलब वो उल्टा चलना शुरू हो गया था. अब मैं आपको इसमें समझाता हूँ. मेरा बच्चा हुआ ये कि हमारी जो करंट थी ना, वो मेन ग्रिड से ट्रांसफार्मर में आने लगी. ट्रांसफार्मर जो है वो जो स्टेप अप ट्रांसफार्मर था वो स्टेप डाउन ट्रांसफार्मर बन गया फॉर अ माइनर सेकेंड्स. क्योंकि मैंने आपको क्या कहा था कि नाउ दिस इज योर प्राइमरी कॉइल एंड दिस आर योर सेकेंडरी कॉइल. अब मेरे बच्चे जब करंट यहां से आ रही है तो प्राइमरी कॉइल ज्यादा, सेकेंडरी कॉइल कम है, तो स्टेप डाउन हो गया. नाउ इट बिकम स्टेप डाउन और उसने स्टेप डाउन होके जनरेटर को मोटर बना दिया. एंड हमारी मोटर जो है वो रन करी थी एंड within a 2 seconds our rpm was approximately 120%. हम 120% पे पहुंच गए थे and it was a time when our whole plant was shaking.
Sir,
ठीक है. Yes.
sir, sir, generator में key of turbine तो नहीं होता. ओ मोटर में
क्या नहीं होता?
मोटर में key of turbine नहीं होता. लेकिन सर फिर इलेक्ट्रिसिटी key कौन से key में कन्वर्ट होती है सर?
मेरा बच्चा देखो, अब मोटर में ना, लाइक फॉर एग्जांपल इफ यू टॉक अबाउट द फैन, तो फैन पे जो आपके विंग्स हैं, आपके फैन के विंग्स हैं, वो एक किस्म की टरबाइन की तरह एक्ट करते हैं. ठीक है. आप क्या करते हो, व्हाट यू डिड इन द बेसिकली व्हाट इज द एप्लीकेशन बिहाइंड द फैन्स रोटेशन. सो व्हेन यू टॉक अबाउट द फैन, उसमें होता क्या है, फर्स्ट आपके पास आप लाइक लेट्स आई एम डिस्कसिंग द फैंस. सो मेरा बच्चा फैंस में होता क्या है, फर्स्ट यू आर एंटरिंग द करंट. ठीक है. यू आर एंटरिंग सम वोल्टेज ईएमएफ आप एंटर कर रहे हो. दिस ईएमएफ इज एंटरिंग इनटू द मोटर. ठीक है.
ओके.
So this motor is actually converting this EMF into the mechanical energy,
Sir,
which is the turning of a fan.
sir,
Yes.
thank you for your explanation, sir. It's break time right now. We'll meet you after 45 minutes, sir.
Okay.
You may take a.
Okay. Okay.
Okay, sir. Thank you.
Okay. Welcome.
सर 11 o'clock पे फिर क्लास स्टार्ट होगी.
Okay. 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 That's good. No issue.
इंशाल्लाह सर फिर मिलते हैं.
Inshallah. Inshallah.